let's see if we can name this molecule using the sometimes called the RS system or the Cahn-Ingold-Prelog system. And the first thing to do is just to see if there are any chiral centers in this molecule. If there aren't, then we don't even have to use the RS system. We could just use our standard nomenclature rules and we'd be done. So if we look here, this carbon is attached to 3 hydrogens. So it's definitely not attached to 4 different groups. Same thing about this carbon right here. This carbon right here is attached to a fluorine, but then it's attached to 2, you could view them as 2 methyl groups. So it's the same group. So this is also not a chiral carbon or an asymmetric carbon. This carbon right here is attached to a hydrogen and 3 other carbons, but each of these 3 carbons look like different groups. This carbon is attached to 2 methyls and a fluorine. This carbon is attached to 2 hydrogens and a bromine. This carbon is just a methyl group. So this right here does look like a chiral center. It does look like a chiral carbon, and the other ones don't. This is just a methyl group, has 3 hydrogens, so definitely not attached to 4 different groups. And this is attached to 2 hydrogens, and those are obviously the same group. So this is also not a chiral center. So we have one chiral center. So the RS naming system will apply. But a good starting point will just to be naming it using our standard nomenclature rules. And to do that, we look for the longest carbon chain here. And let's see, if we start over here, and I don't know what direction I'm going to name it from yet, but I just want to identify the longest chain. If we went from here, we have 1, 2, 3. We could either go to 4 or to 4 there. So we definitely have 4 carbons. 4 carbon longest chain. Longest chain. So that tells us that we will be using the prefix but, or it will be a butane, because they're all single bonds here. So it is a butane. But to decide whether we branch off, it doesn't matter whether we use this CH3 or this CH3. They're the same group. But to decide whether we use this as part of the longest chain or we use that, we think about the rule that the core chain to use should have as many simple groups attached to it as possible, as opposed to as few complex groups. So if we used this carbon as part of our longest chain, then this will be a group that's attached to it, which would be kind of a, what is this, a bromo-methyl group, which is not as simple as maybe it could be. But if we use this carbon in our longest chain, we'll have 2 groups. We'll have a bromo attached, and we'll also have a methyl group. And that's what we want. We want more simple groups attached to the longest chain. So what we're going to do is we're going to use this carbon, this carbon, this carbon, and that carbon as our longest chain. And we want to start from the end that has it's closest to something being attached to it. And that bromine's right there. So this is going to be our number 1 carbon, our number 2 carbon, our number 3 carbon, and our number 4 carbon. And then we can label the different groups and then figure out what order they should be listed in. So this will be this is a 1 bromo, 1 bromo. And then this will be a 2 methyl right here. 2 methyl. And then let's see, just a hydrogen. Then 3, we have a fluoro. So on carbon 3, we have a fluoro. And then on carbon 3, we also have a methyl group right here. So we also have a 3 methyl. So when we name it, we put in alphabetical order. Bromo comes first. So this thing right here is 1 bromo. 1 bromo, and then alphabetically fluoro comes next. 1 bromo, 3 fluoro, 3 fluoro. We have 2 methyls, so it's going to be 2, 3 dimethyl, and remember the D doesn't count in alphabetical order. Dimethyl, dimethyl butane, because we have the longest chain is 4 carbons. Dimethylbutane. So that's just the standard nomenclature rules. We still haven't used the RS system. Now we can do that. Now to think about that, we already said that this is our chiral center. So we just have to essentially rank the groups attached to it in order of atomic number, and then use the Cahn-Ingold-Prelog rules. And we'll do all of that in this example. So let's look at the different groups attached to it. So when you look at it, this guy has 3 carbons and a hydrogen. Carbon is definitely higher in atomic number on the periodic table. It has atomic number of 6, hydrogen's 1. And you probably know that already. So hydrogen is definitely going to be number 4. So let me put number 4 there next to the hydrogen. So hydrogen, and let me find a nice color To do it, I'll do it in white. So hydrogen is definitely the number 4 group. But we have to differentiate between this carbon group, and that carbon group. And the way you do it, if there's a tie on the 3 carbons, you then look at what is attached to those carbons. And you compare the highest thing attached to each of those carbons to the highest things attached to the other carbons. And then you do the same ranking. So the highest, and if that's a tie, then you keep going on and on and on. So on this carbon right here, we have a bromine. Bromine has an atomic number. Bromine has an atomic number of 35, which is higher than fluorine, or which is higher than carbon. So this guy has a bromine attached to it. This guy only has hydrogens attached to it. This guy has a fluorine attached to it. That's the highest thing. So this is going to be the third lowest, or I should say the second to lowest, because it only has hydrogens attached to it. So that is number 3. The one that has a bromine attached to it is going to be number 1. And the one that has a fluorine attached to it is number 2. So this is the number 2 group. And just as a reminder, we were tied with the carbon, so we had to look at the next highest constituent. And even if this had 3 fluorines attached to it, the bromine would still trump it. You compare the highest to the highest. So now that we've done that, let me redraw this molecule so it's a little bit easier to visualize. So I'll draw our chiral carbon in the middle. So let's draw our chiral carbon. And I'm just doing this for visualization purposes. And right here we have our number 1 group. I'll literally just call that our number 1 group. So right there, that is our number 1 group. It's in the plane of the screen. So I'll just call that our number 1 group. That's our number 1 group. Over here, also in the plane of the screen, I have our number 2 group. That is our number 2 group. So let me do it like that. So then you have your number 2 group, number 2, just like that. And then you have your number 3 group behind the molecule right now, the way it's drawn. Let me do that in, well, maybe I'll do that in magenta. So then you have your number 3 group. It's behind the molecule, so I'll draw it like this. This is our number 3 group. Number 3 group. And then we have our number 4 group, which is the hydrogen pointing out right now. And I'll just do that in the yellow. We have our number 4 group pointing out in front right now. So that is number 4. It's number 4, just like that. And actually, maybe this one, actually, let me draw it a little bit clearer so it looks a little bit more like the tripod structure that it's supposed to be. So let me redraw the number 3 group. The number 3 group should look a little bit. So this is our number 3 group. Let me draw it a little bit more like this. So number 3 group is behind us. Number 3. And then finally, you have your number 4 group in yellow. Your number 4 group, which is just a hydrogen, and that's coming straight out. So that is coming straight out of, well, not straight out, but at an angle out of the page. So that's our number 4 group. I'll just label it number 4. It really is just a hydrogen, so I really didn't have to simplify it much there. Now, by the RS system, or by the Cahn-Ingold-Prelog system, we want our number 4 group to be behind, to be the one furthest back. So we really want it kind of where the number 3 position is. And so the easiest way I can think of doing that is you can imagine this is kind of a tripod that's leaning kind of upside down. Or another way to view it is you can kind of view it as an umbrella, where this is the handle of the umbrella, and that's kind of the top of the umbrella, that would block the rain, I guess. But the easiest way to get the number 4 the number 4 group, that's actually a hydrogen, in the number 3 position would be to rotate it. You could imagine rotate it around the axis defined by the number 1 group. So the number 1 group is just going to stay where it is. The number 4 is going to rotate to the number 3 group. Number 3 is going to rotate around to the number 2 group, and then the number 2 group is going to rotate to the number 4, where the number 4 group is right now. So if we were to redraw that, let's redraw our chiral carbon. So let me scroll over a little bit. So we have our chiral carbon. I put a little asterisk there to say that that's our chiral carbon. The number 4 group is now behind. I'll do it with the circles. It makes it look a little bit more like atoms. So the number 4 group is now behind where the number 3 group used to be. So number 4 is now there. Number 4. Number 1 hasn't changed. That's kind of the axis that we rotated around. So the number 1 group has not changed. Number 1 is still there. Number 2 is now where number 4 used to be. So number 2 is now jutting out of the page. So number 2 is now jutting out of the page. Number 2 is now jutting out of the page. And then we have number 3 is now where number 2 was. So number 3 is there. Number 3. And now that we've put our fourth group behind the molecule, we literally just figure out whether we have to go clockwise or counterclockwise to go from 1, 2 to 3. And that's pretty straightforward. To go from 1 to 2 to 3, we have to go counterclockwise. We have to go counterclockwise. Counterclockwise. Or another way to think of it, we're going to the left. Counterclockwise, at least on the top of the clock, we're going to the left. And so since we're going to the left, this is S, or sinister. This is S, which stands for sinister, which is Latin for left. So we're done. We've named it using the RS system. This molecule is S. S, sinister. 1 bromo, 3 fluoro, 2, 3 di.